Welcome, ladies and gentlemen. Today we're going to talk about coordinate geometry and parallelograms. So make sure you have your notes and we'll get started. Alright, so by now we're going to show that quadrilaterals is a parallelogram by what we learned yesterday. So we want to put this in our notes, okay? We can show that both pairs of opposite sides are parallel by using the slope formula. We can show that both pairs of opposite sides are congruent by using the distance formula. And then we can also show that the diagonals bisect, which means cut in half. They cut each other in half. And we're going to use that by using the midpoint formula. Alright, here's our first example. We're given the coordinates A, B, C, and D. And then I drew out my coordinates a little bit so I could see visually where they're at. Now we have to show that the pairs of opposite sides are parallel. In order to do that, we're going to use the slope formula. So m equals y2 minus y1 all over x2 minus x1. So when we do this, we're going to plug it in here. So we have to do both sides. So I'm going to use line 1 and line 2 because they're opposite sides first. So line 1, I am going to use A and B. So A is 0, 1, and B is 4, 4. I'm going to plug it in, so slope equals, I'll call this x1, y1, x2, y2. So if I plug this in here, I'm going to get 4 minus 1 all over 4 minus 0. So I get 3 over 4. So that's my slope on line 1. I'm going to do the same thing for line 2. So line 2 up there uses C and D. So C is 12, 4, and D is 8, 1. I'll call this x1, y1, x2, y2. Now we're going to go ahead and plug it in. So m equals, my y2 is 1 minus 4 all over 8 minus 12. When I simplify that, I get negative 3 over negative 4. But two negatives make a positive. So since I get 3/4 and 3/4, these ones are indeed parallel. Now I'm going to do the same thing for line 3 and 4. So line 3 is up here. I'm going to use B and C. So B is 4, 4, and C is 12, 4. So my x1, y1, x2, y2. M equals 4 minus 4 all over 12 minus 4. So I get 0 over 8. If I simplify that, I'm just going to get a slope of 0. Do the same thing for my line 4. So line 4 is right here. I'm going to use A and D. A is 0, 1, and D is 8, 1. So this is my x1, y1, x2, y2. And I'm going to plug this in. M equals 1 minus 1 all over 8 minus 0. So I get 0 over 8, which again simplifies to 0. Since both of these are the same, these lines indeed are also parallel. Alright, so we just showed that both sides are parallel. Now moving on, we've shown that things are parallel. Now we can show that things are congruent. In order to do that, we're going to have to use the distance formula. So distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so we have to do it for both pairs of opposite sides. So first we're going to do with line 1 and line 2. So for line 1, we're using A and B. So I'll call this x1, y1, x2, y2. Plug it in. So my distance equals the square root of negative 5 minus a negative 2 squared plus 7 minus 3 squared. Now I can go through and simplify this. So my distance equals the square root. This turns into a positive. So negative 5 plus 2 squared plus 7 minus 3 squared. Simplify this up, I get distance equals the square root negative 3 squared plus 4 squared. Type that into my calculator, and I'm going to get distance equals the square root. Negative 3 squared is a positive 9 plus 4 squared, which is 16, which is the square root of 25, which equals 5. Okay? Now, in order to be congruent, line 2 must be the exact same thing. So when I do line 2, I'm going to use C and D. So I'll call this x1, y1, x2, y2. So line 2, plug it in, distance equals the square root. X2 is 6 minus 3 squared plus 2 minus 6 squared. The distance equals square root. 6 minus 3 is 3 squared plus 2 minus 6 is a negative 4 squared. Type that in. I'm going to get distance equals the square root. 3 squared is 9 plus negative 4 squared is a positive 16. So the distance equals the square root of 25, which equals 5. And these are indeed the same. Now, ladies and gentlemen, we could go on and we could do the same thing for line 3 and 4. We would have to show that it was really both sides were congruent, but I think this is enough example to put in our notes. So if you would also just add on the bottom that we would also have to show that lines 3 and 4 are congruent. And we would do that using the distance formula, just like we did the other two. Okay, but for time's sake, we're not going to do all 4, but that is how we would show that both pairs of opposite sides were congruent. All right, moving on. We're given the coordinate points A, B, C, and D. We need to show that the diagonals bisect each other. So I drew it out over here, and I'm going to put in both my diagonals, my blue one and my black one here. Okay? Now we need to show that they bisect, so their midpoints have to be the same. So for this one, we're going to use midpoint formula, which equals, midpoint is x1 plus x2 all over 2 and y1 plus y2 all over 2. So when we go ahead to plug this in, I'm going to do the blue line or the black line first. So I'm going to do the black line. So I'm connecting B, which is negative 3, 4, and D, which is 3, negative 5. So I'll call this x1, y1, x2, y2. So I'm going to plug this in. So M equals negative 3 plus 3 all over 2, comma, 4 plus a negative 5 all over 2. Solve this, I'm going to get M equals 0 over 2, negative 1 over 2, and we can rewrite this as 0 and negative 1/2. That's the point in the middle of the black line. Now, in order for them to bisect, the blue line also has to be the same. So when we talk at the blue line, we're looking at A, which is 0.30, and C, which is 0.3, negative 1. So we plug that into the midpoint formula. So M equals negative 3 plus 3 divided by 2, and 0 plus a negative 1 divided by 2. So my midpoint equals 0 over 2 and negative 1/2, which simplifies to 0 and negative 1/2. And this, ladies and gentlemen, is our correct answer. Okay? All right. Moving on to our last example. Our last example here, we need to find our third missing side. So in order to do that, I'm going to graph this out. And I'm going to graph my points. So I have -2, -3. Here's A. 4, -3. There's B. And C is 3, 2. So here it is, and our goal is to find D over here. We don't know what D is. What we do know is that opposite sides are parallel. So I'm going to find the slope of CB. So C is going to be 3, 2, and B is 4, -3. So I call this x1, y1, x2, y2. And we're going to plug this in right here. So we're going to plug it into our slope formula. So m equals y2 minus y1 all over x2 minus x1. So we plug this in. My y2 is -3 minus 2 all over my x2, which is 4 minus 2. So here I'm going to get -5 all over 1. Now, to find my missing one, I'm going to plug it back into the slope formula. So I don't know D, and I need to know A. So I'm going to use D, and I'm going to use A. So this is going to be my x1, y1, x2, y2. And we're going to plug it in here. So to finish this one off, I'm going to say y minus a -3 all over x minus a -2 equals -5 over 1. And I'm going to set them equal to each other. So I'm going to put this up here. I have two equations. Y plus 3 equals 5, and I have y plus 2 equals -1. Solve these, x plus 2 equals -1. To solve this, subtract 3, so y equals 2. Solve this one, we're going to subtract 2, so x equals -3. So my point is -3, 2. Alright, that's all I have for you, ladies and gentlemen. Enjoy the rest of your day, and I will be seeing you soon. Bye.